So we looked at what is a polynomial and we looked at the uses. Now we'll see how it's actually done. I told, okay, these are the uses, but how do they actually do it? How do they convert a real world problem to something that is mathematical and graphical, and how do they derive a solution out of it? So we're going to look at it and we're going to use a particular example to do this. So this is an example which you guys are familiar with. Okay. So you are hired by a Drop Me Private Limited. So there's a company called Drop Me Private Limited, and you give an interview and they hire you. Right? You go with your bag and it's the first day of your work. You go inside, and when you go inside, after some time they tell, so as of now you have to design a machine which gives the total amount to be paid by the customer at the end of her or his ride. So this company is to do with people taking up cabs. Okay, so people wait for the cabs, and when the cabs come, they sit in that and they go. Is it not? And end of the thing, they have to pay a particular amount, and that amount is generated by the system, and that is paid by the customer. I'm sure you guys would have seen this, or this in different versions also, maybe not in cabs, maybe even in buses, even in trains, this is done. Right? Even in planes and whatever modes of transport which is not your own, you have to pay, is it not? So there it's not done, calculation is generally not done by the persons. As of now, pretty much everyone has a system. So that system is designed by a person, and that person happens to be you. So the company tells there are specifications, and those specifications are, there are two charges that we have to consider. The first is a fixed amount. Fixed amount has to do with things like, you're paying for the company for the services, and whatever distance you travel, that amount is not reduced or increased. Reduced or increased. You have to by default pay that amount. Maybe it might be related to taxing and stuff like that, but you have to pay that amount. Second amount is dependent on the distance the person travels. So if a person is traveling for a particular distance, he or she has to pay rupees 20 depending on the kilometers they travel. Design such machine is your job, to design such machine. See, whenever you have to design anything, you always have to start with making or understanding it in the simplest form. To do that, taking a specific input or specific condition and thinking about it is important. Once you think about a specific input or a condition, then you convert that to statement form, and then you convert that later into an equation form. Okay, and then you take a few particular cases and apply it over there, and then you will be able to, end of it, you will be able to design a machine which is suited to this particular scenario. Right? So we are looking at all of this plus the coding aspect as well, which will help you get an overall picture, a practical aspect. Other than the uploading it to a device, we are doing almost A to, not Z part, at least X or Y. A to Y part we are doing, and the last part is something which we are not doing. If not, we are pretty much covering all the aspect that will come into picture when you are handling such real life scenarios. So to begin with, let's think about a specific case. So we're looking at a person traveling 10 kilometers. Okay. So the amount that the person has to be paid, let's figure that out. See, by default, this person has to pay 30 rupees. Okay. And 20 rupees depending on the distance they travel. In this case, they're traveling 10 kilometers. Right. So we have 30 plus 20 rupees per kilometer. So for 10 kilometers, it is 20 into 10. Is it not? So 20 per kilometer tells that, okay, so if you're traveling 1 kilometer, the amount you have to pay is 20. If you're traveling 10 kilometers, what is the amount? So then, since this is directly proportional, right, you have to do something like this kind of multiplication. So x is equal to 10 into 20, and that's what we have written over here. So basically this person will be paying 30 plus 200, that is 230 rupees. Okay, now let's make use of this understanding and write it in a statement form. So your statement will go like this. Okay, so the amount the person has to pay, right, will be equal to, first is what, 30 rupees. 30 rupees is what they calling it as fixed charge, fixed charges or fixed amount, plus, and the next is the distance dependent charges, that is let's call it as travel charges per kilometer, and this is being multiplied with what, the distance the person travels. Make sense? And this is your statement form. Okay, so writing this is not convenient. It's not convenient while you're coding, it's not convenient while you're mathematically doing it on a paper. So just instead of this, we are writing some other way, and that other way is nothing but your equation form. So we're going to give names to this. So the amount, I'll give it a name as A, right? So in place of amount, I'm writing it as A. In place of fixed charge, since it's already 30, I can write it as 30. If not F, I can write it as F, plus the distance the person travels, I can write it as D, and the travel charge per kilometer, I can write it as T. So again, we had a specific case that we looked into. With this understanding, we made a statement out of it, mathematical statement, and that we converted to equation. Now, since we know that the value of F and T are fixed, so instead of writing this way, I can also write it as 30 plus 20D. Now, instead of writing 20 into D, this is a better representation. People understand that. So D is not something which we can predict. A person can travel 1 kilometer, 1.5 kilometer, 111 kilometers. I don't think that will happen, but who knows? It might be 25 kilometers, right? So it can be anything. Actually, this is possible. Not city cabs per se, but yeah. So this is not fixed. So basically, this amount, right, is dependent on this particular variable, right? Because it can change. That's why it's called as variable. So to tell that, okay, this amount is dependent on the variable D, I'll represent this way. Okay, right? So this is read as A of D. So if you have seen the basic maths, you know that whenever you use this, we read it as of, right? So A of D. What if A was dependent on something else? You would have written it as A of D, comma, say fixed charges keeps changing. You can write it as D, comma F. But yeah, this is not something which we'll be looking at least not in your high school maths. But it's not too complicated. I would prefer that you learn all of this. We will use this in physics actually. I'll use it over there and hopefully you can relate it and understand better. But yes, this is an equation form of this particular scenario. Okay, this particular scenario are converted to an equation form. It's as simple as this. Okay, So people make studies. I told you economist, I told you that biologist, they have to study a particular scenario. So they study and they make a prediction, a quick prediction, or uh, something is already known, and they do their calculation and they get to compare with the actual data. Okay, right? So when both are equal, then the scientist will be like, okay, my thinking is right. Let me put it in equation form. Let me convert statement form first, and let me name them, give them different names. So distance is d, and this is t. And once they convert it to equation form, they tell, okay, this is already fixed and this is already fixed. So let me put those values, and then look at what is the left out variable. So they analyze it. Okay, this has to be in variable because that will keep changing depending on the scenario, and then they represent the entire thing in this format. And this is very important, telling what the amount is dependent on, right? Making d the independent variable and a the dependent variable. Okay, so this words also has to be understood and learned. So in the next video, we'll understand and make use of this equation, and we will create a program, and we will see if you are doing it right and if your thinking is right.